Hi, so today in this video we are going to be covering chapter 5.3.1, which covers the properties of exponents, so product, quotient, and power rules. As we start with this, there are a few things that we want to know. I've covered this in very many videos on my channel in the past, but just as a refresher, we'll go over the exponent rules. So if we have something like x to the m times x to the n, that will give you x to the m plus n. And we can show this by doing something like x to the third times x to the second. And really, if we think about this, expanded is x times x times x 3 times, and then times x 2 times. But when you add them all together, it equals 5, right? So x to the fifth, which is x to the 3 plus 2, right? So that's why that works. If you have something like x to the m divided by x to the n, that's the same as saying x to the m minus n. And we can show that by doing x to the third divided by x squared. That can be expanded to be x times x times x divided by x times x. You can cross those guys out and you get x to the 1. Which is the same as x to the 3 minus 2. If you have something like x to the negative 3 or negative m, that's the exact same as saying 1 over x to the m. If you have something like 1 over x to the negative m, that's exactly the same as saying x to the positive m. You just switch it up or down depending on where you need to go. Well, I guess it'd be like that. And the reason we can show this by doing x to the m, like 3, divide by x to the 4, which is x times x times x, divide by x times x times x times x. Cross those out, you get 1 over x, which is the same as x to the 3 minus 4, which is x to the negative 1. So that's why that rule is a thing. If you have something like x to the 0, it will always equal 1. So for instance, if you have something like x to the 3, and the reason why this exists is because of our previous rule. So if you have something like x to the 3 over x to the 3, that's exactly the same as saying x to the 3 minus 3, which is the same as saying x to the 0, right? But anything divided by itself is equal to 1, right? So that will always be the case. If you have anything to the 0th exponent, it will equal 1. Our final exponent rule is if you have something like x to the m to the nth power, that's the same as saying x to the m times n. And a way to show that is if you had x squared to the third power, that's the same as saying x squared times x squared times x squared 3 times, and then expanding that further, x times x times x times x times x times x, which is the same as x to the 6th, which is the same as x to the 2 times 3. So those are our main exponent rules that we will be dealing with in this chapter and the next chapter. Not chapter, but section. So now, we will use those rules to solve some of the equations in our homework. So we have this question that says simplify the expressions, which is s times s to the 5th. With our exponent rules, we're multiplying x. Oh, I forgot to mention. Those exponent rules only work if you have the same base. So for instance, if you had something like x to the third times y to the squared, that would not be xy to the 3 plus 2. You wouldn't be able to combine them. It'd stay like this, basically. Same for dividing, same for, it works if, with like the negative 1 and stuff still, because, so like if you had something like x to the third times y to the negative 2, that's exactly the same as writing x to the third divided by y squared, because only this one moves down, the x stays up, right? And then if you have something like x to the third times y squared to the second, we'll say to the 4th power, it will distribute. So you'll have x to the 12th times y to the 8th. So that's one thing to keep in mind. So with this one, we're adding these together, so it'll be s to the 6th. This one we're still going to be adding, so 8 plus 6 is 14, plus 4 is 18. So t to the 18th power. They all have the same bases. This one is negative 6 to the negative 6 squared times negative 6 to the 9th. That will give you negative 6th to the 11th, because 2 plus 9. This one says to simplify the expressions. When you have a fraction and it's being multiplied like not multiplied, but it's to the 2nd power, the power applies to both the numerator and the denominator. So you'll have something like 2 squared, so negative 2 squared divided by y squared. The 2 will apply to both the top and the bottom terms. So 2 squared is the same as 4, and then divide by y squared, which just stays y squared. And we'll keep that negative. No, we won't keep that negative because it's inside this parenthesis, so it will be positive because we have a negative times a negative. And then times, this is not our answer yet. We're still here. And then times, this one will apply to both still. And this one will keep the negative, so negative because it's to an odd power. So we'll have 2 cubed, which is 8, over y cubed. So 4 times negative 8 is the same as, it will equals 32. And it will stay negative because we have a negative times a positive. So negative 32, and then y squared times y cubed is the same as y to the 5th. So we're just multiplying straight across. So this would be your answer. Same idea here. We'll do the 10. Actually, one nice thing that we have here. Oh, I'm so dumb. Well, not dumb, sorry. Don't use that word. I am so goofy. An easier way that we could have done the previous thing is these both have the same base. So we could have just added these exponents together and gotten negative 2 over y to the 5th, still in parentheses. And then we could have distributed, and it would have been maybe easier. So that'll be what we do in this one. You don't have to distribute it quite yet. We'll get into that a little more. You can. It works out. It just is a little bit longer of a road. So we'll have 10 plus 9 plus 8, which is 19, plus 8, which is 27. So we have 3 over 8 to the 27. And I'm not sure if it wants us, because that's a pretty big number. So let me get to that question that we're on, because that would be kind of bonkers. Let's do, so 3 to the 27 divide by 8, because that's going to be a huge number. You aren't going to be able to fit it in. Oh, whoops. Wait, why did it mark that right? Hold on. It's being goofy, being silly. Okay. Fair enough. Anyway, so what it wants, the format that it wants it in would be 3 to the 27 divided by 8 to the 27. Yeah. For that answer. And then for this next one, they have the same base, so we can add them together. We'll have s to the 11 divided by t to the 11. And that would be your answer for that one. For this one, same idea, except for, so we'll have 2 plus 7, so we'll have negative 6t to the 9th, and that applies to both. I don't believe that they might want you to calculate that, but let me just see. So we have negative 6 to the 9th times t to the 9th. Okay, so the way that it wants it shown would be negative 6 to the 9th times t to the 9th, and that works. That would be correct. The next one we can add them together. So 5 plus 11 is 16, plus 8 is 24. So we have 8 over 7 t to the 24th, in parentheses still. This will be 8 to the 24th divided by 7 to the 24th times t to the 24th. And that would be your answer for this one. And then for the C, it will be 3 times y to the 10th, which is the same as square root 3 to the 10th times y to the 10th. And this one's a little trickier because I'm not sure if they want it to be, one second, let me see if my fears will be confirmed or not. It's not actually scary, it's just different. And then times y to the 10th. Let's see if it works. Yep. Okay, so this is perfectly fine. In some classes, which I doubt is not the case in this class, but you could simplify this further. But it's okay. You don't need to worry about it. Because this is basically like 1/2 times 10, which is 5. But yeah, it's a little more tricky than that, but sort of like that. And that would be your answer right there. This is acceptable. This one says simplify the expression. We know that this multiplies out, so we have x to the 18th, we have t to the 99th, and we have negative 5 to the 9 times 7, which is 63. And you probably still want parentheses around that negative 5 because it does change the value. Anyway, that's all of the questions I have for this. If you have any questions, please let me know. I will answer as soon as I can. Have a good one.